Now I will discuss Gibbs free energy, delta G, which tells you if a reaction is spontaneous. So, the interesting thing about this is that for delta G, it does not require outside energy source. So even if a reaction takes forever, it does not require an outside energy source. But in the human body, you cannot wait forever for a reaction to occur, which is why we have enzymes to help catalyze and speed up the reaction. But how do enzymes do that? We will see through this graph and later on throughout the course. So one example I want to give about how delta G functions in a reaction, how it works in a chemical reaction, is to show the example in glycolysis where you have glucose and a phosphate, which becomes glucose 6-phosphate, and I'm going to designate that as the first Gibbs free energy. And you have ATP, which goes into ADP plus the phosphate. So you can get rid of the phosphates, and you have delta G2 here. And the sum of this equation, or chemical reaction, you'd end up with glucose plus an ATP molecule, which converts into glucose 6-phosphate plus ADP. And this is delta G3. This should be overall negative for this reaction to occur. So the sum of these two should give an overall negative delta G in order for the reaction to be spontaneous and favorable. So if I were to show this in a graphical format, you have delta G1, which starts in the bottom, which is highly endergonic, because you need energy for this to occur. So delta G1. And here would be the transition state. And here you have delta G2, which is highly favorable. Of course, these values you can find in a book or search online to figure out the exact values. And then if you sum these two, you should get an overall favorable reaction, delta G3. So the greater the potential energy, the greater the energy released, and the greater amount of work which can be accomplished. Energy released is only because it was not at equilibrium. It is far from the equilibrium position. It acquired its elevated potential energy here in a process that required the input of energy. So basically, in the end, delta G, including equilibrium, KEQ, they are both measures of a reaction's tendency to proceed spontaneously. And yes, that's basically most of what you need to know about delta G for now. And that's about as depth as you can get into biochem.